I'm Shabudari OM. I'll be taking you further mathematics, and we shall be considering vector. Vector, you know, in your physics, you have done something in terms of quantities. You talk of vector quantities and scalar quantities. And here we are going to the physical aspects of mathematics. Then when we talk of the application aspect. So in this case, we shall be considering components of a vector in 3 dimensions. Remember we said vector is a quantity that has both magnitude and direction. So we shall be seeing, remember in your SS1 days, you are not strange to this particular topic, but then it was in 2 dimensions. When we hear 2D, 3D, they mean 2 dimension or 3 dimension. So for this, we shall be going straight to example. Now recall that a vector in 2 dimensions is given as, let's say, xi plus xi plus yj. This is a vector in 2 dimensions. Let's say r is equal to xi plus yj. This is x component, this is y component. But in this case, we shall be considering a 3 component in 3-dimensional vector. So let's see example. If r1 is equal to x1i plus y1j plus z1k, and you have another vector r2 is equal to x2i plus y2j plus z2k. Now, all the operations that can be performed on a 2-dimensional vector can as well be performed on a 3-dimensional vector. So, for example, if we want to find r1 plus r2, that will mean, remember we told you that when you are adding, you add component wisely. So x and x will go together, y and y will go together, z and z will go together. So we have something like x1 plus x2, the component I, plus y1 plus y2, the component j, plus z1 plus z2, and the component k. So in this case, we have r1 plus r2 to give us what we have here. All right. So the next one, like we have addition, we can also have subtraction. We can have all those terms. So we can also move. We can get the modulus. The modulus of r1. The modulus of r1 is the magnitude, and it's the same thing as the square root of x1 squared plus y1 squared plus z1 squared. So when we have something like this, then we say we have the magnitude of, then we can also find the unit vector. Okay, this is modulus. Then the unit vector. The unit vector, what is the unit vector? The unit vector of r1 in the direction of r1 is given as the vector divided by the modulus. The vector, that's vector r1 divided by the modulus of r1. And what is our vector r1? That is our x1i plus y1j plus z1k divided by what is our modulus? The modulus is the square root of x1 squared plus y1 squared plus z1 squared. So that is modulus of a vector. Likewise, we can also have the direction cosine. The direction cosine. Direction cosine. The direction cosine is talking of the angle between the 2 components. So for this term, now since it is 3, we are going to be having our angles to be alpha cos alpha, cos beta, and cos gamma. Cos alpha, cos beta, and cos gamma. So for direction cosine, to get the direction cosine in terms of the first vector, then it will be cos alpha 1, which is equal to what? The component over modulus, that is x1 divided by the modulus of r1, which is what? x1 divided by square root of x1 squared plus y1 squared plus z1 squared. The same thing is also for cos beta, which is y over square root of x1 squared plus y1 squared plus z1 squared, and cos gamma is equal to z over, z1, y1, z over square root of x1 squared plus y1 squared plus z1 squared. So these are the direction cosine. So let's see an example. Example 1. Find the direction cosine of the following. Find the direction cosine. Find the direction cosine of the following. One. R1 is equal to what? 2i minus 5j plus k. And 2, that's equal to minus 3i plus 2j minus 6k. Now we want to find the direction cosine of this. So we have R1 is equal to 2i minus 5j plus k. The direction cosine for this particular one will be, where's our direction cosine? We have cos alpha 1 is equal to x over the modulus of, so we have cos alpha 1 is equal to 2, that is, that's x1 over, modulus of r1, which is equal to 2 divided by the modulus. The modulus of r is what? The square root of 2 squared plus minus 5 squared plus 1 squared. And that will give us 2 divided by 2 squared is 4 plus 25 plus 1. 4 plus 25, 29 plus 1, 30. So this will give us 2 divided by square root of 30. You can leave your answer like this, and you can go forward to reducing it to fraction and decimal, as the case may be. And after getting this is your direction cosine. In some instances, they can ask you to find the angle. Then you know what to do when it comes to finding the angle. You just take the arc cos of the inverse of cos. You get your alpha. So for cos beta 1, it will be, what is our beta 1? Minus 5 divided by square root of 30, and cos gamma 1 is what? What's the coefficient of k? 1 divided by square root of 30. So that is for that one. Then you do the second one by yourself. Now let's try and find the unit vector. Okay, from example 2. Find the unit vector. In the direction of, find the unit vector in the direction of the following vectors. Following vectors. Now, when we are given this, R1 is what? R1 is 7i plus 2j R1 is 7I plus 2J minus 3K. Then R2 is 3I minus 5J minus 3K. So, okay, in the direction of 1, the first one is R1 plus R2. R1 plus R2. The second one, R2 minus R1. And the third one, 2R1. Okay. So, the first one says we should find R1 plus R2. The unit vector of R1 plus R2. So what we need to do is to first of all perform the operation R1 plus R2. What is our R1? 7I plus 2J minus 3K plus 3I minus 5J minus 3K. And that will give us 7 plus 3, 10. 2 minus 5 minus 3J minus 3 minus 3 minus 6K. So the next thing is to find the unit vector. How do we find our unit vector? The unit vector in the direction of this is the vector divided by the modulus. So in finding the unit vector now, unit vector is R1 plus R2 with cap is yes, it is the vector with cap, and is given as the vector R1 plus R2 divided by the magnitude or modulus of R1 plus R2. So what is R1 plus R2? That's 10I minus 3J minus 6K divided by magnitude of this will be the square root of 10 squared plus minus 3 squared plus minus 6 squared, which is 10I minus 3J minus 6K divided by 10 squared is 100 plus 9 plus 36. And that will give us what? 9 plus 36. So that will give us 10I minus 3J divided by square root of 145. So that will give us the unit vector in this direction. So because of time, we will not be able to move further this level, but I want you to practice this and this with this other one. Where is that? Yes, this one as your assignment. I will try as much as possible to retype them and put them in the assignment corner. So let's solve it, and in next class we'll meet again. Have a nice day. Thank you.